Welcome to homework.
This is the answer to Chapter 30, problem number 6 from the Smith Organic Chemistry textbook. And in this problem, we are asked to draw a lecithin in which one of the side chains is palmitic acid and the other is oleic acid. And so in order to solve this problem, we need to know what a lecithin is. And we need to know the structures of palmitic and palmitic and oleic acid. And so a good place to start with this problem is to draw the glycerol backbone. And so we can start with that. And so there's our basic glycerol backbone that all triacyl glycerides are going to have in common. And then remember that the defining characteristic of a lecithin is that one of these bonds is going to be a phosphodiester bond. So we can go ahead and put in, the phosphodiester. And then the other part of a lecithin, or the substituent on the phosphodiester is going to be CH2, CH2, charged nitrogen, right? And so that part is what makes a triacyl glyceride a lecithin. And so that's the lecithin part. And then we just need to account for each of the two side chains. And so we can start with the palmitic acid. So we can do that. And then palmitic acid, make that a little bigger. Palmitic acid is going to be CH2, 14 carbons here, and a CH3 group here for 16 carbons total. So 1 carbon in the carbonyl, and then 14 in a CH3 group. And so that is our palmitic. And we can go ahead and label that. Palmitic. So there's our palmitic side chain. And then oleic acid is going to look like this. So carbonyl there, 7 CH2 groups in a row. So there's that. And then a carbon-carbon double bond. So that carbon's going to have a hydrogen and be bound to another CH. And then we will have 7 more CH2s. And then our terminal CH3. And so this is going to be our oleic acid, our oleic acid. And then we'll also label this. Remember, this substituent, this phosphodiester substituent, is what makes a triacyl glyceride a lecithin. And so that is the answer to Chapter 30, problem number 6.